Hello! So today we're going to go through and basically show you the tools I use to develop and write code as well as debug Vampire. So this isn't actually going to be about Vampire itself for the most part, but all of the software I use to edit it. As you can see from the video, I work on Windows. So for the first part of this video, we're going to focus on some of the things you'll need to work with Vampire in a Linux environment on Windows. And after that, we'll move to some more general stuff with using Visual Studio Code as your main editor for both building and running Vampire. So first of all, let's start with what we need to do all this on Windows. Windows has a Windows Subsystem for Linux feature that you can use. This needs to first be enabled. There's plenty of documentation on this if you just look up installing WSL on Windows 10. There's a few different ways to do it. The only main thing that you have to be aware of is that there is now a second version of WSL, WSL2, that has improved performance and works basically as a virtual machine inside of Windows. If you go to this website, for example, it will explain everything about how to install the correct version of WSL so that you have everything ready to go. Once you do have WSL, you will need to install a distribution of your choice. So that's shown here. And to do that is quite simple. You just open up the Windows Store and look up your preferred Linux distribution. There's a few of them. Oops. For now, we'll just go with Ubuntu. And this will install very quickly. Right. And once it installs, you can open it from here. If you lose that, then simply typing Ubuntu into your start menu will bring it up. You will need to create a user for the Windows Subsystem. So here I'll just use Daniel and a password. And there you go. You've got a working Ubuntu subsystem. This is full-fat Ubuntu. You can do anything that you would normally here, including installing any programs using apt-get. If you're on a Windows Insider build, this even includes ability to open graphical or GUI programs. So you can do pretty much anything here that you would do normally on Linux, with a slight performance hit, of course. Before we move on, I'll also show you one more useful thing if you are going to be using this, which is the Windows terminal. That is a very nice, more modern looking terminal that you can use on Windows for PowerShell and CMD if you prefer, but it automatically integrates this Ubuntu subsystem that we've just installed. So again, you can find all the installation information on Microsoft's website, but in essence it's very simple. You just need to go to the Windows Store again. And you'll find the Windows Terminal. There's also Windows Terminal Preview, which has slightly newer features, but either one will work. So I already have this installed, so I'll just launch it. Once again, if you don't want to launch it from the store, then it should just show up in your start bar. Yep. So by default, the Windows terminal will open a PowerShell prompt, but this can be changed in the settings, and we can choose the Ubuntu subsystem we've just installed, so we can just save that. And now if we open a new window, we should, yep, there we go, we'll be greeted with our terminal. This terminal is highly customizable, and so on my actual desktop I've got it set up to look a lot prettier and work with everything that I would need on a daily basis. Hey, just me from the future. Just wanted to point out this is the terminal that I use on a day-to-day basis. There's plenty of customization for it, so as you can see here, if you go into the settings, you can change things like the background. So here, for example, I've got a custom font and a background picture set, in this case from a Studio Ghibli film. And you can also do some nice stuff such as change the prompt appearance. To do this I use something called Oh My Posh. And actually the shell I'm using isn't plain bash, but I use the fish shell, which just helps with remembering commands you've put in the past, some auto-completion basically. If you're interested in either of those things, you can just look them up. Just look up Oh My Posh to change how the terminal looks, and the fish shell, which is used instead of bash. So this is what you'll need to run everything I'm about to talk about on Windows. From here on, everything will apply to both Linux systems or working on Apple computers. The only possible difference is that the Mac users will probably need to use something like Homebrew or Mac ports to install the next two components. So the next two things we need is a working C++ compiler. So we can use the GNU C++ compiler, GCC. And to get that from our Ubuntu terminal, we can just type in sudo apt-get. Oh, actually, the first thing we should do is probably update this, otherwise it's not going to work. Update, sudo apt-get update. So apt-get is, of course, a package manager used in Ubuntu. Sudo gives it root privileges to install something to your system. So we've just updated it, and now we can install build essential. Oops. Is it essentials? What is it? I always forget what the exact thing is. Ubuntu build essentials. It's install build essential. There we go. So build essential installs a few different things. The things that we are interested in, a lot of them are very useful, so I'd recommend you installing the whole thing. But the main things that we're going to be using are G++ and GCC. In this case, it's going to be GCC 9, which is a relatively recent version of the C++ compiler, which Vampire works with very well. You do need to confirm that you want to install it, and it will quite quickly install everything for you if you're on a good internet connection. It might take a little bit longer, but it's only a matter of time. There we go. So we can just confirm that it has installed by checking the version of G++. There we go. So we've got G++ running on Ubuntu version 9.3.0. In addition to G++, we'll also need GDB, the GNU debugger, I think it stands for, I can't remember exactly, but basically it is a free debugger that can be used with C and C++. This is typically a software run on the command line, and you can learn the commands to use it for debugging a C++ program. But we just need to have it installed, and we will instead be allowing VS Code, Visual Studio Code, to do all the heavy lifting for us. First we need to install it. There we go. And again, we can check that has installed. Yep, so we've got everything working properly. Right, so from here on out, we don't actually have to use the terminal anymore because we'll be getting our built-in terminal in Visual Studio. So the next thing we'll want to do is install Visual Studio Code. Again, just search for it on Google and you'll find an easy download for all available platforms. I know that it runs on a Mac, it runs on Linux, and many other systems as well. I'll just check that I don't already have it installed. Visual Studio Code. Nope. Yep. Actually, we will need to use the Ubuntu terminal one more time to install Vampire. So if we launch Visual Studio now, it will ask you if you want to install the Windows Subsystem for Linux WSL extension. We can install, you can either click install here, or there is also a slightly more complete remote extension that you can install. I like to use that. Remote development, and just install that. There we go. So I'll close this for now and we'll install Vampire. So to get Vampire, just head over to GitHub, github.com/RichardEvans/Vampire, and copy the link from here. And then in your terminal, find the directory you'd like it to be kept in. I'll just put it in the home directory. And use git clone and then the link. And now we can go into the newly created file and we'll see that everything is there. We can also change to a more recent branch because this is currently on master. So the most recent branch I worked on is VDC, so we can use that. And actually from the terminal, there is very good integration with the outside Windows system. So for example, you can open up the Explorer from here. And you'll see all the current files we're looking at in Windows Explorer. And you can open Visual Studio Code by simply typing code space period. And that will automatically install the Visual Studio Code server for WSL for you. All right, there we go. So we're in Visual Studio Code and it is connected to WSL, as you can see in the bottom left. We will also need a couple of extra extensions. So we will want a C++ extension. This includes IntelliSense, debugging information, and code browsing. So it will also highlight everything and allow you to look through the Vampire code more easily. And we can install that automatically to WSL. And to build Vampire, Vampire uses makefiles, and so we can install a new extension developed by Microsoft for makefiles in Visual Studio Code. Makefile tools, which is a new extension to Visual Studio Code. It's still in early stages of development, but will work for building Vampire. We'll have to make a couple of changes to then debug the code without it. So we can get that. So now we can browse and look at the Vampire source and get all sorts of information. Just from the IntelliSense C++ extension. So from here, you can already start to develop for Vampire, add to the code. GitHub integration is also built in, so any changes you make will show up here. So if I just add another line and save, you will see that a change has now been made, and these can be automatically be added and committed to GitHub from VS Code. Again, there's plenty of documentation on this if you'd like to look for it. VS Code is very widely used, which is why we can use it with Vampire so easily. So, the next thing we'll want to do is build Vampire, and that's actually quite easy. To do that, all we need to do is set a configuration. So VS Code and its extensions create a new folder, .vs Code, in your workspace directory. So you can see that here at the top of the directory. This will automatically create a settings.json file. As you can see, it's very plain right now. We can add a few extra settings to make building Vampire a little bit faster. So makefile configurations, I think. Expected a comma. There we go. And now let me remember what it is. It is, so now you can start adding a setting, and I think the first one we'll want is make args, and to this we can add -j4. Okay. And it will also require a name. We can just call this config. There we go. Yep. There we go. So this creates a configuration, which we can see. So here, if you just look at the sidebar, there is a makefile tab. We can now choose the configuration. The makefile extension automatically goes through the makefile in the home directory of Vampire. So we can see that here. Here's the makefile. The makefile is basically just a recipe for building Vampire, and it has all of the flags that are used when compiling each of the C++ files. So for example, we can see the debug flags for GCC, including -g for debugging, some profile flags, and then a bunch of extra warnings for finding inconsistencies or bad conversions from different unsigned to signed integers, that kind of thing. So what we can do is choose a target. So this is what you would use when you're typing in make into the terminal. So if we just use serial, for example, we can use serial on its own. That would just make the Vampire serial executable. Or we could go for serial debug, which will include all the debug flags, so that we can then go through and debug the code. And then finally we can use a launch target, and that will be Vampire serial debug. So once we do all that, we can use this button to build the project. This will take a little bit of time, but it's basically just building all of Vampire. Of course, in the settings file, I've used -j4, that is to compile 4 files at a time. It uses all 4 of my desktop's cores at the same time. If you have a Mac with more cores, or have less possibly, and a smaller laptop, you can of course change this as you need. There we go. So that's built successfully, and in fact, if we go to the terminal here, so we've just got the Ubuntu terminal that we were looking at before, and we'll see that we now have a new executable Vampire serial debug, and we can run this to run the usual test case for Vampire. This probably will take quite long, so we'll just stop it after a second, but as you can see, it's running Vampire as per usual, although quite slowly, I assume because it's running in debug mode. Yeah, so how do we go about debugging Vampire? So one of the ways we can do it, actually, you can do this very easily if you want to. So to debug in Visual Studio Code, the main thing you'll need is to add a breakpoint to the program so that you can stop and look around. So for example, if we simply set a breakpoint here in Simrun, we can actually click on this button on the top left for debugging, and Visual Studio will do everything for you. And in fact, you will see that we have stopped at the breakpoint. We can see the current local variables. The only downside to doing it like this is that GDB is not in pretty printing mode, which means that if we do find things to look at, they won't be easy to parse. So let me give you an example. If we just go into the run function, so over here on the top we have different buttons that we can use to move forward and backwards through the program as we're debugging. So we can use F5 for this button to continue, step over, step into, and step out of different functions. So here in run, if I just make a new breakpoint in this for loop, there we go. We can see our local variables are m, which is still 0 at the beginning of the loop. We've got this num_atoms for statistics, and then we have an array. And you'll notice if I try to expand the array, I instead get information, complicated information about the array itself, not exactly what I'd want to go through to actually try and see what's in it. So all of this is perfectly usable information, but not particularly useful for me. So if you want to do it this way, what you can do is into the debug console here on the bottom, you can type in -exec, I think it's enable pretty printing, probably with a dash. Yep, there we go. So now if I move forward, there we go. We can now see if we try to look at the array information, it contains one element, which is false. But this is slightly annoying because we'll have to do this every time we run. What we can do instead is we can create a launch config. So I'll just stop this here. And if we go to this Run and Debug tab in Visual Studio Code, we can create our own launch config. Simply click on Run and Debug, choose GDB, If you're using Cray, for example, you'd have that suggested here instead. Yep, we want to use a config for G++. Abort. There we go. So we've got a launch.json, and that's failed because this is normally how things are set up. Don't worry about that. Right, so we do need to edit a couple of things for launch.json, so I will just look these up now. So the two files are basically the same, but the changes will just allow us to get this working. So all we need to do is change the program. So instead of this line here, I'll just copy paste this. We also need to change the args. Stop at entry is the same. Need to change the current working directory. And I think everything else is the same. Ah, yes. The one thing we need to leave out is this pre-launch task. We don't need to build the project again, so we can just comment that out. I'll delete this file. All right, there we go. So now if we go to the Run and Debug tab, this will use that configuration. You'll see that it has the same name, G++ build and debug active file, which is the same as this. If we want to change it, that'll be absolutely fine. In main, yep, we've still got our breakpoint at simrun. So we can now hit the play button. And apparently I've added an extra. Oh, I probably didn't need this line, did I? Yeah. I will just remove that. If you were passing extra command line parameters to Vampire, then you would need to use that line. So let's try again. There we go. Right, so now that's working properly. We'll go back to where we were last time and we'll see that pretty printing isn't enabled automatically. That's set over here. Enable pretty printing for GDB. Also, there's a few different things that we can do. So the variable section on the left tells us all about all the local variables. You also have information about registers. But if you want to, you can use the watch section to keep track of things you're particularly interested in. So if I, for example, if I add, for example, the first element of non-magnetic materials array, we can just type in the name, magnetic materials array. And we can use the index, index 0, and that will tell us what it is currently. So even if I have this minimized, that will still show up. And this will also persist if we move to different functions. That will stay here even if it's not in the local scope. Even when the value changes, we will notice the change here, and it's much easier to keep track of in general. You can also do some simple maths here. You know, if you have one variable that you'd like to look at the result of a sum with another variable, you can do that in the watch menu. Also underneath that, we've got the call stack, which is very useful if the program fails. When the program encounters an error, you will get a message, and the debugger won't exit immediately. Instead, you will be able to go through the call stack and find where the error occurred. So in fact, we can see here that we are currently in the top stack frame is here in the function simrun. But if we go to a different stack frame, we can see that we are also still in main.cpp, we're running in this function over here. So when the simrun function exits, we will return to this frame. Also, finally, we can disable and enable different breakpoints that we have set around the program from the very bottom. So there's a decent amount of flexibility, and for the most part, you should be able to run any command that you would normally in GDB using Visual Studio Code's GUI instead. And so you might have some small include errors, but for the most part, you shouldn't have any problems. Using this, you can debug Vampire. As per usual, I've used this to write code for VDC, the Vampire data converter, and it works absolutely fine, both for running and building and debugging. So I think that should be everything you need to develop for Vampire on pretty much any platform. I always use Windows, and I've had no issues whatsoever. Previously I was on a Mac, and I didn't use Visual Studio, but I don't think you would have any problems with it there either. So yeah, enjoy.